Hello friends, in this lesson I will discuss how you can create Numpy array. Before we dive into Numpy array, first create a Python list which contains 5 elements. So here is the Python list, and in order to see the element of this list I will use this variable, and it has returned the elements stored inside the list. In order to know the type of this list, we will use type function. Now I will create a Numpy array from this particular list which has one dimension. So I will also create Numpy array which is of one dimension. When you will pass this list to the Numpy array function, it will create one dimensional list. Before we start working with Numpy, we need to import it first. So what I will do is I will import Numpy and will give it a alias np. I will use numpy as np once it is imported. Because it is a one-dimensional list, so I will create a one-dimensional array obviously, and I will have to give it a name which suits that particular array. So let's give it a name np1. The function that will create array from this particular list is array function, and to this function I will pass list. So the np1 contains numpy array which contains these elements. In order to see the elements, you will write np1 and it has returned the array which contains these list of elements. You can also pass it a list directly rather than passing the list. You can also pass it list directly, and if you will see its element, the elements are same. So there is no difference how you are going to create your list. Right now, if you want to see the dimension of the array, what we will do is we will use the np.ndimensional attribute, and it says that, I'm sorry, I wrote it wrongly. I need to write np1 and then n dimension. It says that the array which we have got is of one dimension now. And in order to know the shape of the array, what you will do is you will use another attribute called np.shape, and it has returned you 5, which is quite confusing maybe, because you would be thinking that it should be 1 and then 5 because it's a one-dimensional array, which is not the case. Over here it says that the shape of the element is indexed by a single index which contains 5 elements. Bit confusing? No problem. I will discuss another example wherein you will get to understand it in brief. As of now, stay with this and understand that this is a single dimensional array with index 5 and contains 5 elements. Okay, so what is the size of the array now? In order to know the size of the array, you need to type np1.size, and it is going to return you the size of the array, which is 5. Okay, let's create a two-dimensional array, right? So that you can understand the purpose of shape in brief, so that you may not get confused how it is going to work. So I'm going to create a two-dimensional array now. To create two-dimensional array, I will give it a name np2, and the function is nparray. And to this function I'm going to pass a list of lists. So I'm going to pass it to list for now, and it contains elements like this. So here is our second numpy array, and it has been created now. In order to see the elements, just type np2, and it says that it's a two-dimensional array. So this is the first row and this one is the second row. In order to know the type of the array, I did not discuss it, I believe. So in order to know the type of the array, what you do is you need to use the variable name and then dtype attribute. It returns you the type of the element that are stored inside this array, and it says that the type of the elements that are stored inside the array is integer 32. You should understand one thing, that when you are going to declare array, all the elements of the array should be of same type. You cannot mix types within the array, so that's not going to make sense. So it has automatically assigned it a type integer 32, and that states that every element is of 32 bit, right? So the next attribute that I wanted to discuss is the shape. So the variable is np2 and shape returns 2:5. It says that there are 2 rows and each row contains 5 columns, right? So I hope you understood. So in previous example it says that 5, it means the array is of one dimension containing single index with 5 elements. Over here the scenario is different. Over here we have got 2 rows with 5 elements in each row. In order to know the size of the array which we have created just now, we are going to use size attribute, and it says that the size is 10. Alright, so in this particular example, or in our previous example, when we created an array, it automatically assigned it a type. Now what if you want to assign your own type? Let's suppose you want to assign it a type floating point 32-bit or 16-bit, rather than allowing it to assign the integer type. So what you will do in that case, I'm going to use the same list, and to this I'm going to pass the type that we need to assign it. Now in order to know all the types, you need to just type np dot and then press tab. Over here you can search out what are the various floating point types available with us. It is 64-bit, which is commonly used. I am going to assign it 32-bit, right? So here it is. The array has been now created, and let's check the type of this particular array, the newest array which we just created. So over here I'm going to write np2 and then dtype. It says that the type of the array is, the array element is floating point 32, right? And if you will see the elements, it says that the elements are floating point now. There is another important attribute which is called item size. The item size is going to return the size of each element. We got to know what is the type of the element which is floating point 32 as of now. If you want to know the item size, how you will get to know that? It's very simple. The attribute is item size. I am going to write np2 and then item size, which is going to return you the size of the each item, and it says that 4. The floating point is of 32-bit, right? And it has got converted to the bytes. In order to convert this particular type to the byte size, what you will do is you will divide it by 8-bit, because 1 byte is equal to 8 bits. 32 divided by 8 returns 4, and it means each element is of 4 byte. If you declared your array, let's suppose you want to declare an array of 1 dimension. Let's give it a name np1 and pass it an array np.array, and the list of elements are 1, 2, 3, 4, 5 and so on. And this is our new array now, which contains 6 elements. In order to know the type of this particular array elements, you will use dtype, which is going to return 32-bit. Again, if you want to know the item size of this particular array elements, what you will do is you will use np1 dot item size, and it will return you 4 again. I hope you got my point. If you would have assigned it another type, let's suppose np dot let's assign it a 64-bit integer type, and let's see what is the current type now. It says that the type is 64-bit integer, and if you will check the item size, now it says that it is 8 byte because we have assigned it a integer 64-bit type.